Yeah, it was under more. Hello, everyone.
Hello.
Hello, hello. And I see we've got 24 folks here. Welcome. We're going to give folks I think that there was a time crunch in trying to get everyone over from the last session. So we're just going to give everybody about 30 seconds. Hi, Kiana and Graciela, Marvin. Marvin, hi. Good to see you. Marvin was in a cohort with me for, oh my goodness, I'm blanking out on the name, but we were in an early education fellowship cohort together. It was good to see at least your name. Welcome, everyone. Hi, Heather. Oh, now it's so fast I can't read all of them. Kiri and Laura, welcome, everyone. We are at 34. Maybe I'll give it about 15 more seconds and then we will get started. I hope everyone's having a good Friday morning. Thank you for spending it here learning about math. And we'll get started just to make sure that we finish on time. Good morning, everyone. I guess afternoon now. My name is Brenda Gardner. I'm the curriculum supervisor for Tandem Partners in Early Learning. We are a nonprofit here in the San Francisco Bay Area. We work primarily in San Francisco, Alameda, and Contra Costa counties. But every now and then, through the magic of the internet, we venture out all the way to Fresno and other parts of California. And our primary goal is to increase access to early education programming for families and children around the communities that we serve. And we do that in a couple of different ways. We do that through our main program, which is a home classroom to home book sharing library that functions in formal school spaces, so Head Starts and the school districts that we partner here in the Bay Area. And then we also provide playgroups and workshops for families, but also we provide professional development for educators. So I think that's going to be part of the resources that we send afterwards, just the links on how to join us on the internet. We're going to be having 20 sessions of professional development, all free through Contra Costa First 5 this coming school year. So if any of the topics that interest you, that we're offering interest you, they're free to join. So you just have to register, and those registration links will be going out later in the year once we get all of the calendaring scheduled. But I'm here with my colleague Cecilia, so I'm gonna let her introduce herself as well.
Good afternoon, everyone. My name is Cecilia Valdez. I am a curriculum specialist at Tandem, and it's so great to see all the different places popping up. I saw Oregon, Brenda. So we crossed.
Oregon. Oh my goodness, and Seattle.
State lines. So yeah, welcome everyone.
Yeah, welcome. So today's workshop, we're going to be talking about making math meaningful for infants and toddlers. There's usually, Florida. Hello, Jennifer from Florida. We typically, right, when we have these conversations around early math, they're really focused on the 5 preschool foundations, which are what do we do? What do kids need to do to be ready to go to preschool? But not a lot of times do we focus on what are those precursor knowledge bases and skills that are going to help our infants and toddlers get to preschool to be able to really hit the ground running and work more intentionally on all those kindergarten readiness goals. So we're going to be talking about that today. And the 2 objectives that we have in this workshop are to understand the 5 math, infant, and toddler learning foundations and how they relate to the preschool foundations, and how to incorporate these 5 learning math foundations for infants and toddlers into your class, or if you are a parent that stumbled into this conference, then how to be able to do that as well. So, and I've lost Cecilia. But Cecilia, if you're there, feel free to chime in. I lost your little display.
I'm here, but I don't know the screen. I can't see your screen.
Oh,
yeah.
Is everyone else having an issue with my screen?
Yeah, I thought you just were sharing.
Yeah, the slides aren't showing right now.
Okay, let me try that again. Thank you for letting me know. All right, can folks see them now?
Yes.
Perfect. So to get us started, we wanted to review a little bit about, what are the 5 preschool foundations? So we're going to run through those very quick and not spend a lot of time going into them. But the first one is number sense. And if I can get just like a couple folks in the chat to tell me a little bit about what you know about number sense when it comes to preschool foundations. What do we mean by number sense? And we'll give a couple seconds.
I see.
Yes, yeah, like counting, right? And we're talking about counting both in order, so being able to say 1, 2, 3, 4, 5, all the way to 10, 20, but not just being able to count in order, but being able to recognize the numbers 1 through 10, and being able to have one-to-one correspondence, right? So when I'm counting, I'm not just going 1, 2, 3, 4, 5, 6, 7. I'm stopping and pointing at each item, and the meaning of real life of numbers, absolutely, right? So then when I'm counting, when I'm doing my one-to-one correspondence, and I stop at 7, and somebody asks me how many cookies, how many M&Ms, how many whatever do we have, right? Then we know that the answer is 7. So being able to get those really basic one-to-one correspondence numbers, number recognition, starting to write the numbers and being able to understand what they mean. And if I say, get me 3 M&Ms, right, then children are able to count them and bring me 3 M&Ms. Then the second one is algebra and functions, primarily classification and patterning. Of course, they're not doing big complicated equations, but they are starting to be able, or they are able to classify objects by whatever category we give them, right? Give me, whether it's size, whether it's color, whether it's their function as well. So let's sort all of the things that you might take to the beach, for example. And with patterning, they are able to recognize patterns, simple A-B patterns, more complicated A-B-C or A-B-B patterns, right? So red, blue, what do you think comes next, and be able to make those predictions. Or if it's a complicated A-B-B, so red, blue, red, blue, what comes after. And yes, Marvin, attributes, being able to identify the attributes of objects and things, and be able to vocalize them, and then make classifying those by the attributes that they are being given. What about measurement? I love that folks here have speedy fingers, because since I can't see you, I'm like, type. And Kiana said sorting and classifying by 1 or more attributes and patterning. Yes, thank you. And Jennifer said non-standard units. Yeah, absolutely. So at this point, right, we don't expect them to know that there are 5,280 feet in a mile, or that what 10 inches looks compared to a yard. But they're starting to play around with how many shoes might this be? How many shoes do you think that the toy snake is? And do you think that what is taller, what is shorter, what is bigger, what is smaller, and really starting to play around with the idea of volume, particularly when you're at the sensory table and you have two different pictures, and one's bigger and smaller, and asking those questions of, do you think that the bigger picture, the water in there is going to fit into the smaller one, or do you think that it's going to overflow, right? And Kiana said, comparing sizes, measuring sizes, more, less, half full, exactly. And then calculate DAO. Buzz on Gloria. There's a typo, and I'm not sure what you meant by it. And you said eyeballing. Yeah, right. Like, do you think it's gonna, based on what you can observe about the object, do you think that this is going to fit? Do you think that it's taller? Do you think that it's shorter? Do you think that it's more or that it's less, right? If you have a big pile of M&Ms and you have a little pile of M&Ms, what do you think has more in it? Using standard and not standard tools to measure. Yeah, so starting to play around what they left. So we have a play group where we use, Cecilia, do you want to talk about this? We use a measuring tape.
Yeah, we do using actual size. The children make their actual size, so they trace their body, and we play around with using non-standard tools, like how many, if they really have time, how many little paper clips are you, but popsicle sticks, what about post-it notes? And then we come around with a tape measure, and then they start, you know, practicing and like using the tape measure. And it's really interesting. It's really cute to see them, and they start wanting to measure everything. I have a picture like a child measuring their mom's arm. And so it's just those initial, like, okay, now we're gonna look, what does an inch look like? And just play around with the tape measure.
Yeah, and particularly when you're playing around with non-standard units of measurement, right? If you have popsicle sticks and it takes 4 popsicle sticks, but you're also using paper clips, which are shorter, like making those predictions of, do you think it's going to be more paper clips or less paper clips based on the attributes that you can observe on this specific unit that we're using to measure. And they need to understand all of those to then be able to understand, right? Like that an inch is shorter than a foot, then a yard, then a mile, et cetera, et cetera. And these are the foundations for that. And finally, mathematical reasoning. And I'm going to open the chat again for mathematical reasoning.
I think you skipped geometry.
Oh, I'm sorry. Geometry. Let's do geometry. What do we talk about when we talk about geometry? Yeah. Shapes, spatial relationships. Jennifer, you're getting ahead of us. Space and shapes. Yeah, right. So being able, at its core, being able to identify a triangle and a square, and perhaps starting to play around with 3-dimensional shapes and being able to learn, name and understand those, but also being able to know why this is a triangle and that's not a triangle, right? Being able to vocalize that, well, I know that a triangle has 3 sides, so let's count the sides. Oh, this shape that we're looking at has 4 sides, so can it be a triangle or can it not be a triangle? And why? So if it's not a triangle because it has 4 sides, what do we know? What can we see about the shape that might look and make you, and go into your mathematical reasoning, right? Based on what I know about other shapes, like, okay, well, I know a square and a rectangle have 4 sides, and then breaking it down more specifically, if 2 of the sides are long, or if they're all of the same sides, then what shape do I know that this is? Based on what I am looking at here. And then finally, mathematical reasoning. What do we know about mathematical reasoning? So this is primarily like your thought process, right? Being able to problem solve and to break a math problem or a situation down into its smaller components and identifying like, oh, well, this is where it went wrong. So maybe let's try a variant of what we did here to see if it will lead to a different result, right? And not really focusing so much on the final product, but really the play along the way for all of the the process that we're trying to do. And I see in the chat applying math concepts to describe, absolutely, and then analyzing. Yeah, so again, like really thinking critically about what am I trying to do and what are the steps that I have taken, and did I get the result that I wanted? But again, not focusing on the result. And if it didn't, making adjustments to try something new. And also just getting to experiment, right? Like maybe I had this outcome in mind and I did this and something else happened. And now let's look at what happened and how how that works and how that functions within itself, and like, does it play a purpose? Did I make something cool and innovative? And just really playing around with the creation and the process of trial and error, and not just giving up and being like, that's it. Yeah, so Marisela, exactly, critical thinking, right? Why did that happen? Why did that not happen? What can I try to make the thing that I want happen? And if it didn't, what have I created in the meantime? So those are when we talk about the preschool foundations, right? This is like when we're thinking about a child going off to kindergarten. These are the 5 things that they need to check the boxes, right? But when we're talking about infants and toddlers, they look very similar, but they're a little bit different, right? Because infants and toddlers are developmentally at a different stage. So when it comes to infants and toddlers, the first math foundation is number sense. And obviously this directly correlates with the preschool foundation of number sense. And I'm not going to go into them a ton in here because we're going to break them down one by one and what they look like. But I just wanted to have sort of like the correspondence of what they are for infants and toddlers and preschool. So infants and toddlers also have a foundation that focuses on number sense. You can start thinking about how that might look different, right? From what we know about infants and toddlers and preschools and their abilities. And then we're going to dive into them in a bit. And then classification that also directly correlates with algebra and functions for the preschool foundations. And then someone earlier mentioned spatial relationships and space and size. And this is one that's specific to infants and toddlers that later on informs 2 of the preschool foundations for older children. So spatial relationships directly feed into measurement and geometry. And then the final 2 are cause and effect, which we've also mentioned critical thinking right here, that feeds into mathematical reasoning and also problem solving. So for the infants and toddlers, they get broken up into 2 different aspects of it, cause and effect and problem solving, that are going to inform mathematical reasoning. And I just want to do a time check here. All right, so now we're going to dive into each of them individually. So when it comes to number sense, right, what do you think number sense might look like for an infant and toddler? You can type it in the chat. Does it look the same as for a preschooler? And I see more or less, counting during routines, like putting on your socks and counting 2 socks, lining up cars and counting them. Yeah, thank you. So, or other toys, yeah, singing and rhythm, using appearances to see which was more and less, finger plays, subtract or add things in the song, absolutely, right? So when this foundation at its completion, if you want to think about it that way, children are able to subitize with groups of 3 objects, right? And by subitize, we mean that's when you look at a group of objects and you can immediately be like, that's 3. So think about like the dots on a die, on a dice, right? You don't have to count each of those dots to be able to know that that's the 5 side or the 3 side or the 2 side. And with children this age, they subitize in the sense that they're not going to be able to tell you that's 3, perhaps. But if you give them two, like in the picture, right? 2 hands of M&Ms, and one of them has 5 and one of them has 3, they're able to look and know that the 5 is more than the 3, and that there's a bigger and a smaller group, and will most likely always pick the bigger group because they're able to look at it and estimate a quantity, and differentiate between larger and smaller. And then they begin to use relational words like more and same. So if we're thinking about number sense, right, they're not counting and saying 1, 2, 3, 1, 2, 3. I know that that is equal, and they can't verbalize it, but they're able to see that they look similar, again, that simple subitization, and be able to estimate that what's more and what might be the same. And then by that same hand, right, like what is less. And they're starting to begin to count out loud. So at this stage, it might be a little bit more rote counting. So just reciting numbers that they've heard. And a lot of times you'll notice in this age group that they kind of mess it up a little bit, right? So it's like 1, 2, 3, 4, 7, 15, 8. And that is really important because it is important that children are able to count in order. So then this is where adults can say like, oh, let's try again. Let's say 1, 2, 3, 4, 5, and help them get that sequence in order. And I see a comment in the chat, number sense in the early years helps build a foundation for understanding math concepts in later years. Absolutely. And then Jen said, recognizing how many more bites of food there might be. Yeah, and either it's going to be encouraging and they're like, oh, I have 2, or you're like, oh my goodness, a whole meal. That seems like a lot of bites. I can't even fathom the number because I'm a toddler. But knowing again, that concept that like, it's a lot more than I want to take, right? Any comments? Oh, I'm sorry. And they begin to count small collections of objects. Again, we're thinking really small, 1, 2, 3. And you might count them with them successfully. Again, thinking about that one-to-one correspondence, right? We can slow down and say 1, 2, 3. Can you count them again for me? And then they might say 1, 2, 3, 4, 5, 6, 7. And that's okay, because it's all about repetition and it's all about continuing to try to slow it down and to get those number words and that one-to-one correspondence, and really thinking about like what's more and what's less here. And then I'm gonna let Cecilia, if she wants to add anything, and then folks in the chat, if you have any questions or comments about number sense here.
Yeah, I just wanted to add, and it's something that I'm sure everyone's already doing, which is the modeling that math talk during your day-to-day interactions, which like what Brenda was saying, but even say, if you're all sitting together at lunch and incorporating those relational words like more or same, and then counting, it's like, you know, I have more strawberries than you. Let's see, I have 1, 2, 3, and you have, let's count 1, 2. Now I'm gonna eat 1. Now we have the same amount, right? It's kind of like a day-to-day interaction, and it's really you're counting, you're saying more, same, less. So just kind of day-to-day interactions, how the math talk can really easily be incorporated.
Yeah, and really about slowing it down and making it intentional, right? And yeah, I think mealtime is an amazing time to really incorporate all of that number vocabulary and counting, and really start, like Cecilia said, start to play around a little bit with addition and subtraction, right? Maybe we all start out with 5 strawberries and somebody was really eager to eat the strawberries. Now there's no strawberries. So what happened, right? Like you put all 5, so they got taken away and now there's nothing on your plate. But mommy or teacher or sister or whoever, I've only eaten 1 strawberry. So how many do I have on my plate? And we're not making it super explicit, like 5 minus 4 equals whatever, but we're starting to play with the idea of taking away and adding and having more or having less. And again, with that recognition of being able to look at amount of objects and being able to either count or say there's more, there's less in the quantity of these. Yeah. I eat 1, you eat 1, right? We're playing with number or with one-to-one correspondence. If I'm only holding a little Cheeto or whatever, kids don't eat Cheetos, a healthy puff, and 1 for me, 1 for you, can you please give me 2 puffs, right? Then we're allowing the children to pick up each puff and hand it to us, and we help them count and say 1, 2, thank you. Now let's grab 2 for you, or would you like 3? And making those decisions and really making it a game, a really slow, clear, intentional game about how we're counting and distributing the puff well. Any other comments or questions on number sense before we move on? Let me give that a couple more seconds. All right, and Cecilia and I are going to be in a Q&A group later on. So if there are any questions that we don't have time to answer here, feel free to bring them there. So the next one is classification. Cecilia, do you want to take this one?
Sure. Let me, sorry, go ahead. So like we were talking, classification really is about how children are learning to group and sort and connect objects through their attributes, or like what they can see, right? Like what makes these the same, what makes these different. And even at like a very, very young age, babies are observing the adults in their life, and they have expectations even of like people acting differently towards them, and they can react differently to like an object, right? People and objects are different. But they can also differentiate between smiling faces and frowning faces. And there are two types of categorizations that babies do, or young children do. We think of perceptual, which that's visual. We're learning what makes things the same. Maybe it's like recognizing similar shapes and colors, or objects, right? This is a block and a block, but this is a little flower, right? So how do we sort them? They can look at a ball, and regardless of a color or size, it's still a ball, right? A ball goes with a ball, whether it's really big or it's really tiny. But they can also sort by color, by texture, by a feel of an object. And then thinking also about even animals, they might distinguish animal types, right? Like this type of animal has fur, this one has feathers, this one has scales, and separating pictures of cats and dogs, even if they've never interacted with these types of animals in their life. And then when we think about conceptual categorization, this is like through observation, like how objects or people behave or how they act, right? Or how we use them. So we can group items by like their function. For example, thinking about like utensils, like these are spoons and forks, or these go in one place, we use them to eat, or we use them to cook. We need the pots and pans, and understanding that these objects have different functions and different purposes, but also like observational with people in their lives, right? And their roles, and they can expect different behaviors from their caregivers. But then they can also figure out, like with adults, like who do I go for certain needs that I may want, or who do I kind of like, you're categorizing like even their own needs, and whether it's like feeding or comfort, or even understanding social categories. And then anything you want to add to that, Brenda?
Yeah, and Cecilia already touched on this, but really, again, we were talking about attributes earlier on when we were going through the five preschool foundations. And this is really what infants and toddlers are glomming onto. Like, what are attributes and how can I classify different things based on those different attributes? So like she was saying, is it the purpose? Is it the object that, like, is it a ball, right? In this case, I'm not categorizing by big ball, small ball, red ball, green ball. I'm just saying these are all balls. But within this group of balls, then I could also then say, okay, we're going to sort them by color, right? So now I have to be able to recognize the attributes. Can I eat it? Yeah, can I eat this this material that I have here? But if we're sorting them by color, right, I need to be able to recognize what red looks like, what blue looks like, what green looks like. Did I say green twice? Maybe. And then based on that, I have to identify the attribute, recognize that, and then start to sort through that. Can I eat it, right? Babies are famous for putting everything in their mouth. And this is a way of exploring texture and function, really. Can I eat it? Is it something that tastes good? Is it something that has like a weird, funky texture? Is it going to melt in my mouth? Is it going to scratch my tongue, right? These are all attributes. And even though infants and toddlers might not have the words to verbalize that, they're starting because your tongue is so much more sensitive than your fingers, than the nerve endings on your fingers, right? Like this is a really great way of exposing themselves to texture and by default attributes. So when we see a baby with something in their mouth, you're like, oh, you have this toothbrush in your mouth, right? Like, oh, is it pokey? Is it spiky? And really using those attribute words to help children understand what we mean when we say, don't touch that because it's hot, right? Like to them, that's such like a foreign concept. Like I'm learning what everything is and what language is. But if we touch something that's warm and safe, and or maybe when we go outside, we can say like, oh, it's very hot, right? So we start to understand what is hot and what is cold, what is rough and what is smooth. And then also the function that things play, right? If we're thinking about like this picture here with all of the basket and things, toddlers, if they are part of a preschool or a school, they already do this at cleanup time, right? They're classifying all the toys. We're going to put all the blocks here. And that doesn't mean that we're sorting by little blocks and big blocks. Like all things that we have called blocks go over here. All of the animals go here, right? All of the books go in the library. So we're starting to learn what things look like, where they're places, and sorting them by the attributes that they're being given. And it's a really fun thing for toddlers to see and understand, going back to the ball example, right? That like ball isn't the only category that can be sorted and classified here. There are many ways to do it. So let's play with that and see how many different things. Can we put all the socks together, right? If you're doing laundry. And first we're gonna sort by type of clothing. And then maybe the next category is by like, whose socks are these? Or whose clothes are these? And we put all of baby's clothes in this basket and all of mommy's clothes in this basket. And just really playing around with talking about attributes and trying about concepts and purpose, and how we make different piles of things for ourselves and for others. Any other questions here? And going back to, can I eat it, right? In mealtime, is it sweet? Is it sour? And even if you're not sorting, just having that conversation with children of like, how does it taste? Does it taste sweet like a strawberry, right? Like you can make those mental classifications and comparisons without necessarily having to have all the sweets and all the sours available to you. Okay, and then spatial relationship. What do we mean by that? And this feeds directly into the measurement and geometry preschool foundation that we talked about earlier. Oh my goodness, we're running out of time. We end at 50, right? No, 55.
55.
Okay. Okay, good. Marvin again with under. Yes, this cute child giving us a perfect example of being under the table. What else do we think about when we talk about spatial relationship? Fitting things in different spaces. Consuelo, we did grab these from the California Infant Toddler Foundation. Is there a body in space, positioning, kids' awareness of their environment and how they can move their toys? Absolutely. High, low, far, how much space can a child take up? Awareness when walking, crawling, moving. Absolutely, right? So children are just starting to explore, first of all, how much space does their body take and where is it in space, right? Like it's per perception, and being able to like understand where our body is in space and how much space we take up is something that is happening all of the time. We see it when they're walking, right? Like there's all of these jokes around how infants and toddlers are almost like adults under the influence sometimes, because they kind of walk all over and they fall and they flop and they run into things. And this is all about understanding my body and space, and the objects and where they are and where they start and where I start and other things end. But also all of the things that you were mentioning here with how I move in, how I move in space and the positional places of things, right? If I say go under the table, right? Or the ball is too high, or the ball is too low, or can you send that ball really far? What do we mean when we say all of those words? Understanding that we need to put something in the basket, not under the basket or next to the basket, and how that all influences outcomes and things. And I'm gonna read some more. Priscilla, do you want to add while I look at the chat here?
Yeah. So one of the things that we were, in addition to like understanding where your body is, how your body fits in the space, and then bringing other, I think we were talking in measurement, like even speaking about volume, like what will fit? Will I fit here? Can I crawl through this tunnel? Can I get through this space? Can I fit this object in this hole? Right?
Yeah. Baby is small and he was able to, or she was able to go through this tunnel, right? And now the child is sort of like, mommy, and like, do you think mommy is gonna fit in this tunnel? This mommy is a lot bigger than you, right? Like understanding size difference and how they relate to each other, and also positional things. And again, like Cecilia mentioned, right, when none of these exist in a silo. So when we can relate them back to other foundations as well, like measurement and number sense and other things. Yeah, having things in their nose. Yes.
Oh God.
And why you shouldn't do that and why it might get stuck, right? And being able to vocalize, be like, that's a very small space in your nose, and this M&M. I mean, you can get it in there, but it's going to be really difficult to get it out. So maybe let's not put things up our nose, right? Putting things down the toilet, the number of times, right? Of like, this is why we don't put things in the toilet, because they can get stuck. And what does stuck mean? And why is that an issue? I'm trying to think of other funny examples around things that toddlers do that are problematic for adults, but really thinking about this for them as experimentation, right? They're like, will it fit? This is a genuine scientific exploration of like, is this going to work? Carrie, jumping off high things and tables, absolutely, right? Like for them, they're just like, let's see what happens, because they don't have a concept of that's too high and your body can't handle it. Like, what does high mean and why is that dangerous, right? Like, this seems like fun. And being able to say too high, maybe a step, that would be like, a step is shorter and you can jump off of a step because it's a short distance, right? But you cannot jump off of a table or the top of the slide, because that's a really long way down. And when things and people fall from really high places, they get hurt. So really understanding all of that vocabulary and what it means, and in how really it exists in practicality in the world that they exist in. So not just like some concept in the brain, but really being able to understand it. Yeah. Any questions about, oh, let's see here, trying to fit toys into their pockets, like trying a fire truck into the pocket to take home when it's meant to stay in the classroom. This is a perfect example, right? Like, look, let's slow down. Let's look at your little pocket and let's look at this fire truck. What do you think is going to happen, right? And this isn't going to be a one-time thing that after the first time they're going to be like, oh, you're right, this fire truck is entirely too large for my pocket because I want it. So but if we slow down and we have that vocabulary and we talk about like, maybe if you are allowed to take it, where else could we put this fire truck? Could we put it in your backpack? Could we put it in a basket that you can carry, because your pocket is too small for a large fire truck? And having those conversations. And again, so much of this infant and toddler math foundations are about conversations and guiding infants and toddlers through it and allowing repetition and experimentation. So what happens if we, like drop an egg from here? Is it going to break? Probably not. But what happens if we drop it from here? Or what happens if, like the higher we go, the more it breaks, things like that. Any other questions or comments? Funny anecdotes about things children have tried to put in places they don't belong. All right, so we're going to move on to the next one, which is cause and effect. What do we know about cause and effect? And again, remember that cause and effect and problem solving, which is the next one, both they start out as their own categories, and they're both informing mathematical thinking and reasoning. So what do we know about children, infants, and toddlers and cause and effect? Throw a spoon on the floor over and over. Yes, this is the perfect, most common example. Why do they do that? And then Marisela said sink and float. That's also a really good one. Right? But why would this adorable child continue to drop that spoon from her high chair? Screaming to get a reaction, testing gravitation. Yes. Experimenting to see the reaction and makes a fun sound. Absolutely, all of those. First of all, is my mom going to react? Because I've already done this 100 times, and let's see if I can get another reaction. Yeah, when I do something a lot or something I'm been told I'm not supposed to, and I want to get a reaction, I want to get attention, right? I want attention and no one's paying me attention. So what am I going to do? I'm going to do something that's going to get attention, and I'm going to test out to see which ones get attention, right? I might have a high concept of gravity, or be experimenting with gravity and be like, is the spoon going to fall again for the 100th time? Or is it magically going to float up to the ceiling or be suspending in space? Like, when objects fall off the edge, they always fall. And then not only objects, but like I've done spoons, I've done cups. What about eggs? Do eggs fall, right? And having that cause and effect of like, what is the thing that I'm playing around? And makes a fun sound. A spoon makes a different sound than a cup, and makes a different sound than some scrambled eggs. So let me see, I wonder what sound this is going to make, right? It is fun, yes. So children begin to better understand, again, the properties of objects, right? And you touched on this, great, and also the patterns in human behavior. What gets a smile out of folks? What gets a please stop? What gets an indifference? They just take away the object. What gets a hug? What gets me more treats, right? Cause and effect, again, playing with relationships and cause and effect, and consequences, and just understanding, like we mentioned, properties. Does it make the same sound? Does it make a different sound? Which all of this helps them understand their own behavior, and others' behavior, right? Going back to the relationship, right? If what I want is attention, which kind of attention do I like best? Do I like the hug and the kiss better, or do I like the indifferent, like the still face experiment that, super famous? But the babies try all kinds of things because they're like, okay, historically, when I smile, mommy smiles back. And when that doesn't happen, there's a disconnect. So they start to try all of these different things of like, do I kick? Do I scream? And eventually it ends in frustration, right? Because that is the loudest of the actions that can be taken to get attention. But the point is, I want attention. So make predictions. What do I want the outcome to be when it comes to attention? Or just really, again, exploring with, will it sink or will it float? Like someone mentioned earlier, right? If that's what I'm playing with, and what objects sink and float. But it's a lot easier for infants and toddlers to start to understand why some things sink and float when an adult is having those conversations with them, right? Because think about when you are trying something new, or like trying to build something or a new skill, and you're like, why isn't it working, right? Like, is there a YouTube video that I can play? Is there like a narrator that can be in my ear to tell me why my table is sideways when I follow the thing. And it's the same with infants and toddlers. If we have someone there explicitly saying, you know, oh, I see in the bathtub, we have the little boat, and let's take all the water out and let's see, oh, see, it floats because it doesn't have anything in it, no water in it. But what happens if we fill the boat with water, right? Then it's going to sink because it's full of water. And they're not going to fully understand the concept of buoyancy at this point, but they're going to start to have some idea of, okay, if it's filled with water, it sinks. If it's empty, it floats. If this hairbrush, right, that's heavy, that sinks because it's heavy. Let's drop it in together and then hear the clink at the bottom of the bathtub, right? But this rubber ducky, look how light he is. Do you think he's going to float or do you think he's going to sink? Let's try. And again, they might not be able to vocalize, I think it's going to float. But based on the experiments that you have run together, which is the most important part, right? Like that narration for them. This other rubber ducky floats. Do you think that this one is going to float or do you think he's going to sink? And maybe we get a really heavy, one of those like mallard decorations that people had in the old times, and be like, this one's heavy. Do you think, again, right? Thinking about classification and patterning, these are both ducks. This is a metal duck or whatever, hard plastic duck, mallard, and this is a little rubber ducky. They're both ducks, but are they going to perform the same in the environment that we are? And if yes, why? And if no, why? Right? So what makes things happen and how can we make predictions about the environment that they are in, but also the relationships that they have and are interacting with every day? And finally, because I have 1 minute left, problem solving. So this is, we've mentioned all of these, right? Because this fits into mathematical thinking, which is really the big umbrella for all of these skills. But it is using trial and error to solve an issue. It also involves imitating solutions that they see others perform. And again, this is why the narrative is so important, because if we are describing the reasons why we're doing something, it is more likely that they start to learn to pick the solutions that apply to their problem they're trying to solve and not a solution that's completely unrelated. And then the last one says use objects and people as tools. And that sounds, I know it sounds weird, but again, yeah, again, if I'm trying to get something, a specific outcome, which parent is more likely to give me that, right? To break when I do a cute thing, or which teacher or which sibling is most likely to help me with the problem that I need. And again, objects as well. If I'm trying to reach something, maybe what can I use in my environment to help me reach something? And that something might be my body, right? Is my body the easiest way to solve this problem and reaching out? So thank you all so much for coming. We are at time 1 minute over, but again, Cecilia and I are going to be in a Q&A room after this. So if you have any questions, please feel free to join. And I hope you have a great rest of your day and the sessions as well. Thank you all so much. 50 minutes is not enough. Thank you.
It goes so fast.
I know. Thank you all so much. Have a good afternoon. Thank you. Thank you. Thank you, Marvin. Good to see you. We'll see you all. Well, see you typing. See you. Thank you. Mahalo. Do we have someone from Hawaii here? Carrie Lou Almos? Am I saying that right?
A few of us.
Yes, a few of us. Oh, I want to
Nice.
be in Hawaii.
I know.
It's actually sunny in San Francisco, sort of. There's big fog going that way, but thank you all so much and have a great weekend. Am I supposed to end this?
I think, and then we can go backstage.
Bertha, do I know if we are getting a certificate? Let me get back to you. If Bertha Martinez, are you still here?
If they're still here, once you complete the survey, you'll get a certificate automatically for completing the survey. And then to close the webinar, you will click leave and end webinar for attendee.
Okay.
All right.
Yeah, and Bertha was still here, so she got her answer. Okay.
Good.
Perfect. All right.
And somebody said what survey? The survey link was dropped in the chat. I will. Oh, what survey? All 6. No, there's an end of event survey that when you go to the closing session, when you go back into the lobby, you'll see the link in the lobby to complete the end of event survey.
All right.
And there's an end on the bottom right hand side. Is that the end for here or the end for end webinar for all? Okay, perfect. Well, Cecilia, do you want to stick around? No, let's just sign into the Q&A.
Yeah, because we have 2 minutes.
Yeah. All right. Thank you so much. Bye-bye, everyone. Thank you.